Okay, the title of this is called Rationalize the Denominator. So, do we know what the word denominator means? It's the top or the bottom, you're right. Which one? It's the bottom. 50-50 chance. It's the bottom. So, here's what this means. In a number, you really aren't supposed to have a radical in the bottom. It's not mathy-like to represent a number like this. Okay? So here's what I'm going to do. To get rid of the root 3 on the bottom, I'm going to times it by a root 3. But if I do that to the bottom, what should I do to the top? I should do the same. Okay? All I'm doing is timesing by 1. Look at this. This is just 1. I'm timesing by 1. Does that change the number? No. So what do you get here on the top? 7 root 3. And what does root 3 times a root 3 turn into? Root 3 times root 3 is root 9, which is
3.
Whole number 3. And look at this. The number doesn't have a radical on the bottom anymore.
So you're just trying to get it alone so that
there's no radical on the bottom.
Okay.
That's the goal. Okay, ready? The next one, I don't like the root 2 on the bottom, so I'm going to times it by a root 2 on the bottom. But if I do that, I also have to do that to the top. Which will make, think whole numbers, separating them in your brain, right? Whole numbers, radical numbers. What do you get? 8 root 10 over, and root 2 times root 2 makes a root 4, which is whole number 2. But you're going to lose points if you end here. Because what can you do with those whole numbers? These are whole numbers, whole number. So what is 8 divided by 2? What can you reduce here? 4 root 10. Okay, the last, I'm going to call it single one. This is the last single one. Okay, so what's the thing I don't like? I don't like a root 5. So I'm going to times by a root 5. What you do to the top, you do to the bottom. Okay, so the top is root 15. Okay, now we got to be careful here. So this is a 4. And root 5 makes root 25. Root 25 is whole number 5, which makes 20. Okay? Do we understand that I can't reduce here? Okay? Because this is a radical, this is a whole number. Don't even think about putting them together. Separate. They're on different sides of your brain, right? Are you seeing a pattern? What is the square root of 192 times the square root of 192? Just the whole number 192, right? Are you seeing the pattern there?
It's like 2 negatives equal a positive.
Well, this would be, what? We'll think of it this way. When I do this root times this root, isn't it the same as doing this root squared? And then really what's happening? Okay? Did you notice that happen here? Root 3 times root 3 turned into just a whole number 3. Root 2 times a root 2 turned into a whole number 2. Okay? Okay, number 4 and 5 are different. Why are they different? Let's look at the bottom. On the bottom now, we're not dealing with a singlet. We actually have a binomial. Okay, so this is a binomial. So I'm going to times it by, and then I told you yesterday, I told you a fancy word, and I only used it once, and I said, who's going to remember it today? Conjugate, yeah. Okay, so I might have to get some candy over there. What is the conjugate to this binomial? You have to write, remember what the conjugate was? The exact same thing you see, except for what? What opposite signs? So root 10 minus root 2. Do you remember what a difference of squares is? X plus 3, x minus 3? That's the same thing as a conjugate. It's just the same binomial with a plus minus. What you do to the top or bottom, you do to the top. Okay. Now on the top, how do you multiply a single times a binomial? I need this from you. Can you distribute that out? Okay. Binomial times binomial means I should FOIL, except I can cheat. What happens to conjugate FOILs? Every time that happens. Because look at the outside. What do you have on the outside? Negative root 20. What do you have on the inside? Positive root 20. What's going to happen? Gone. Okay? So you can FLA instead of FOIL conjugates. You get to cheat a little bit. Okay, what is the first times the first? Root 100. Or if you're understanding it, I'm okay if you just write whole number 10. Do you understand conjugates will always have a minus? Because there's always plus minus. So there's always a subtract. What's the last times the last? Square root 4, or if you understand root 2 is just whole number 2, just go there. Look at that. We ended up with no radicals in our bottom. Okay, so this, number 5, would be the hardest I would get you to do. So, again, there's a binomial on the bottom. So I'm going to have to times it by its conjugate. So I'm going to write the same binomial, but with the different sign. Okay, so that's what it's a conjugate. What I do to the bottom, I do to the top. Okay, this was already a binomial and we're timesing it by a binomial. So, sorry, there's no shortcuts. You are going to have to FOIL that all out. And this is a binomial times a binomial. But because they are special, that you get to cheat. Okay, so there's your process. I'm going to let you work on your own. Can you get me all those numbers? You got to FOIL it on the top, and the bottom you can flip. Okay, so how did our top go here? Did we get that on the top? 4 root 15 minus 6 root 6 plus 2 root 35 minus 3 root 14. That was your FOIL on the top? Yes, or are you just copying it now that I did it?
That was my fault.
Okay, how did our flowing go on the bottom? So this would be 4 whole number root 25, always a minus, 9 root 4. So 4 times whole 5, 20 minus 18. So the whole bottom should have come out to just the number 2. Did we get there on our own? Did we get to the 2? Okay. I would go further, except for it really doesn't pay to simplify because this last one is a 3 and then I'd have a decimal. But if you wanted to, right, you could have done 2 root 15 minus 3 root 6 plus just 1 root 35 minus 1.5 root 14.